Problems on differentiation from the first principle. Now let's start with question 1. Given that y is equal to square root of sine s, then let's find the y, the s. So find the y over the s from the first principle. So given y equals to square root of sine s, so the first thing you will do, add small change in y to y. That is this y, add small change in y. So that will be y plus small change in y. So do the same thing for x. Square root of sine x plus small change in x. So the next thing, take this y to the other side of the equation. So this will becomes y, this will becomes the y is equal to square root of sine s plus the s minus y. So because if you take this y to the other side, it becomes minus y. Now what is your y? Look at the real question. Y is equal to square root of sine x. So instead of writing this y, I can write square root of sine s. So the y is equal to square root of sine s plus ds minus square root of sine x, because this y is square root of sine s. As you can see in the question, y is square root of sine s, so I replace it. Now from here we can divide all this by 1. It's still the same, so I'll do that in next step. So this is the y is equal to square root of sine s plus ds minus square root of sine s divided by 1. So I will now say rationalize the numerator. Rationalize the numerator. So if you are rationalizing numerator, that means you will write this twice, but you will change this sign to plus. So that's what we'll do in next step. So that means the y is equal to square root of sine s plus ds minus square root of sine s divided by 1 times square root of sine s plus ds plus square root of sine s. Close the brackets. That is, we change this sign, we change it here to plus. So you now repeat the same thing under. So divided by, replace the same thing. So divided by sine, square root of sine s plus the s plus sine s. So this is rationalized. You know, this can cancel out. It will still go back to the real question. So that means here we have rationalized the numerator. Now multiply the up one. This up one is difference of 2 square. What is difference of 2 square? You know, s square minus y square is equal to s plus y x minus y. Now if you look at this up one, we have square root of sine s plus the s minus square root of sine s, and again square root of sine s plus the s plus square root of sine s, just like x plus y, x minus y. So we change it to s square minus y square. So that is how I will multiply the numerator. So that means I will have dy is equal to dy is equals to square root of sine s plus ds square minus square root of sine s squared. So that means I've multiplied the numerator, this one, and if you like you can expand the brackets one by one, but here I'm using difference of 2 square. So that is the numerator. Then the denominator remains the same, that is square root of sine s plus the s plus square root of sine s. So like that. So now you will notice now that this square will cancel out this square roots, this square will cancel out this square roots. Then we are going to have, so let me clear this so you can jot the solution. So from here, so if that one cancel out, we'll have dy is equal to, so it will remain sine s plus ds minus sine x divided by square root of sine s plus ds minus or plus square root of sine s. So to remain this, so because this square I've cancelled out this square roots. So now from here, how can we now evaluate this numerator, this up one? So from trig identity, so note this identity, sine a minus sine b is equals to sine is equals to 2 cos a plus b divided by 2 sine a minus b divided by 2. Now from this identity we are going to evaluate this up one. So it's like all this a s plus the s is a and this s is b, so it will be sine a minus sine b. Then the expression will becomes 2 cos a plus b over 2 sine a minus b over 2, where a is s plus the s, b is x. So let me write that here, where a in our case is s plus the s and b is x. So if I use the principle here, so I'll get dy is equal to, so this will be 2 cos a is now s plus ds plus b, that is x, divided by 2 sine a minus b, that is s plus ds minus x divided by 2. Then everything divided by So everything divided by square root of sine x plus the s plus square root of sine x as shown here. Now look at the up one. We can see that s plus s is 2x. So our next step, so clearing this, so you can jot everything. I want to bring this one up. Okay, now from here, this is the y is equals to 2 cos dy is equals to 2 cos 2x plus ds divided by 2 sine ds divided by 2. Why? Because we can see here that x minus x will be 0, so it will remain the s, and here s plus s is 2s, so we have 2s here, but here s will cancel out, remaining the s. So divided by, so we repeat this, divided by square root of sine s plus ds plus square root of sine x. Now from here, you can notice these two can affect both 2s and the s. So my next step, I can say dy is equals to 2 cos dy equals 2 cos s plus the s over 2, because 2 will cancel out here 1, and it will divide this one here to show this. So that means the 2 will affect the 2 equation. Let me write it here to see it better. That means the 2 will affect 2 to be 2s over 2. It will also be, I mean this place can be this. So here you can see 2 will cancel out, it remains x. Again, this one cannot cancel, so we write it like that, so as the s over 2. Sine the s over 2, so this will remain the same, so divided by the same. You see, I'm rewriting the denominator, so you don't need to touch that one. So now from here, we will now say divide both sides by the s, that is delta s. Divide both sides by the s. So we will have, so let me just copy this step. So we'll have, if you divide by the s, then this will be divided by the s, and just added the s to this side, meaning you have divided by the s. Because if you say divided by the s over 1, I'm showing that step. So if division change to times, it will change to 1 over the s, so the s will still be here. So take note. Okay, so now I'll do one step here, but let me show you and limits. Now we know that limit s to be 0 of sine s over s is equal to 1. So that means I'll try and change this one here in form of this so that it can becomes 1. So now look at the next step. Now these two, I'll bring it here because it's the same thing. So if the 2 is there, so I can have sine the s over 2 and the s over 2. So that means in my next step, I'll show it as dy over ds is equal to, let me separate it, it's equals to cos s plus the s over 2 sine so divided by, or let's say sine, I want to show that part, times the s over 2 divided by the s over 2. So that is this 2 now is the one I write under this the s. So I now take this one together because it's times. So that means I have it this way now, which will be equivalent to this. And remember, sine s divided by s is 1 when if you limit s to be 0. So take note of that part. So we have achieved that here now. So then let me rewrite this one. Square root of sine s plus ds plus square root of sine s. So like this. Now we will now say limits dy ds as the s tend to 0. So in the next step we have limits dy ds as the s tends to 0, meaning anywhere you see the s here you should put 0. And note that limit sine the s over 2 over the s over 2 will be equals to 1. As you can see here, if the expression here and here are equal, then you get 1, just like this one here. So that means all the expressions there will be 1. So our next step will be, so if you limit, so we'll get dy over the s. Let me show the 0 first. So as we say from this step now, limit dy ds as the s tends to 0. So that means all these ones will be 0. Yeah. So yeah, everything will be 0. Yeah, everything will be 0. S plus 0. So yeah, everything will be 1. So that will be times 1 like this. So we will now have, therefore, dy over the s will be equals to cos x, it's remaining cos s here, divided by square root of square root of sine s plus square root of sine s, like that. So we'll have the y over the s will be equals to cos s divided by, now square root of sine s plus square root of sine s, that will be 2 square root of sine x. So this is the answer. So this is our dy ds. So we have true. That means if y is equals to square root of sine s, dy ds is cos s divided by 2 square root of sine s. We can use power rule to do this to confirm. Now I've done this. If you subscribe to my video, you will see differentiation short methods, but this is using first principle. So y will be the same thing as sine s raised to power half, because square root is half. So now using chain rule, half will come down, differentiate inside, sine s will be cos s, rewrite sine s, then raised to power minus half. So if you change this, it will give us cos s divided by 2 square root of sine s. That is just a short method. That is power rule. So but you can check my video, you will see. Now let's solve the second question. Now this is the answer for this one. So the second question, question 2. Let's say y is equals to tan square x. What is the y, the s from the first principle? So given y is equals to tan square x, so y equals tan square s. So if y is tan square s, then first step, y plus small change in y will be equals to tan square s plus small change in x. Now take y to the other side. So this will be dy is equals to tan square s plus ds minus y. So as usual, what is your y? Y is equals to tan square s. Replace it here. So dy is equals to tan square s plus ds minus tan square x, because y is tan square s, as you can see in the question. Now this is the same thing as dy equals, so let me show it this way. This is the same thing as tan ds, everything square, minus tan s, everything square. As in, this square can be outside, as you see it here now. So this is difference of 2 square. So this is difference of 2 square. So that is the one I used before, x square minus y square is equal to s plus y, x minus y. So that is difference of 2 square. So now if I use this to express, let me write it, from s square minus y square is equal to s plus y, excuse me, then x minus y. So that means my dy will be equals to tan x plus ds plus tan s, then another bracket tan s plus ds minus tan s, tan s plus ds minus tan x. So this is tan x. So with the difference of two square, we got this. Now from here, in trig identity, so note this identity, that tan a minus b is equals to tan a minus tan b divided by 1 plus tan a tan b. So note this identity, this is over 1, so if you cross multiply, then tan a minus tan b will be equal to tan a minus b times 1 plus tan a tan b. So if you cross multiply, so you get this. Now this is now an identity that we will use here. So that means all this is like a, y this is like b. A is like s plus ds, y b is like x. So let's apply it. So this will becomes dy is equals to tan s plus ds plus tan s times, so is all this one I want to write instead of this, so I'm using this identity to express it. So that will be times tan, so tan a minus b, because a is s plus ds, b is x, so that will be tan s plus ds minus x, so bracket 1 plus tan s plus ds tan x. So that's what we have next. So because a is s plus ds, b is s, a s plus ds, b is s, so that's what we just replace here. Check it. So now next step, dy is equals to tan s plus ds plus tan s times, now s will cancel out, so that will be 0. It will remain tan s So that is times tan x, then open brackets, open brackets, 1 plus tan s plus ds tan s. So like this. Now from this step, we'll need to say to divide both sides by ds. So if we divide both sides by ds, so we can say multiply both sides by ds. So we'll have dy is equals to, let me say I want to write this together in one line. Sorry, this one remain, there is typo here. As in when we said s minus s is 0, so it should remain ds, not x. So let me change it. So it's remaining ds here, tan ds instead. Then 1 plus, so I have this. So my dy will be equals to, let me multiply the two together, tan s plus ds plus tan s times 1 plus tan s plus ds tan s. Now this tan ds, so to be times tan ds like that. So that is this tan ds is the one I write last. So tan ds. So from here I can divide both sides by ds. Divide both sides by ds. So if I'm dividing by ds, the only thing that will change here is this one. That will be the y over the s will be equal to, so all this expression here, so the times the s divided by ds, because this tan here, tan ds is the one I'm putting the s under. So that is I'm dividing both sides by ds. It's because there is no space, you can still write it here if you have space. So now, and notice we need to limit now. The same thing we did for the sign, we will do it here also. So let's limit, that is limit the y over the s as the s tend to 0. So to limit the y ds as the s tend to 0, so that means anywhere you see the s here, you turn it to 0. So this becomes tan s plus 0 plus tan s times 1 plus tan s plus 0 tan s, then times 1. All this will becomes 1 because limit the s to be 0 of tan ds over ds is equals to 1. So all this expression is 1. So that means I'll say everything there times 1. So I may not write the 1, but let me show it. Times 1, because all this one is 1 if you limit. So now the remaining thing, so after you limit, then to change to the y over the s, will now becomes tan s plus tan s brackets 1 plus tan s tan s. So the y over the s will be equals to 2 tan x, because 1 tan s plus 1 tan s, that will be 2 tan x, 2 tan x into, if you use this tan s to expand the brackets, so this becomes tan s plus tan square x. So it will be tan s plus tan square s if you expand this place. So and that will be I think this one is outside. Let me recall the rule. Tan a minus b, 1 plus tan a tan b. So that will be tan a minus b. So I want to check something here. So that means I'm having, oh, so the plus, this one is outside, so the bracket is not for all. So the bracket is only affecting tan x. So please take note, is here. So because this is the same thing as tan s bracket 1 plus tan s plus the s tan s, and as we change as in like this, so the tan s outside, so now as we change the s to 0, tan s times tan s will be tan square x. So will be tan square s, this is the s. So take note. So that means this, from this place I have tan s plus tan s, that is 2 tan x. And from here, this one is outside, so let me remove it. Yeah, so I'm doing this so that you can easily see what we are doing. This is one compound bracket, so I open another compound bracket. So 1 plus, so let me do it this way, 1 plus this, 1 plus tan s plus 0 tan x. So here also, let me remove the bracket. So that will be 1 plus tan x tan s. So this will be 1 plus tan square x, because tan s times tan s will be tan square x. Take note of that part and the use of the bracket. So the bracket is not affecting the one, that small one. So it's only affecting the tan x. So now we have dy over the s is equal to, if you expand the bracket, or before we expand, let's use identity straight. There is an identity that sec square s is equals to 1 plus tan square x. So that is the identity I will use now. So I can say dy over the s is equals to 2 tan x. Now 1 plus tan x will becomes sec square s. So we have differentiates. So that means the answer to this question is this. So if we use the power rule, we'll have y is equals to tan square x. Then dy ds, 2 will come down, differentiate tan s, we get s square s. Then we write tan s. You can check my video on the short method, so it shows the answer is correct. So that is the answer to this number 2. Thank you. So please take note of these brackets. Yeah, take note. Let me show that part again. So we use the identity tan a minus tan b to be equals to tan, you can record that part, tan a minus b, 1 plus tan b. So tan a minus b, that one gave us tan ds. Then into 1 plus tan s plus ds tan s. So I'm trying to record this part now. Do you see? That will be tan s, 1 plus tan s plus ds tan s. Then this the s, we've already bring the s under and it has turned to 1. So it's from here. So we now have 1 plus tan s. By the time you limit the s to be 0, then another tan s. So this tan s now is not multiplying this 1, as you can see. It's only multiplying tan s times tan s, and that was why I got tan square s as in yeah. So I'm trying to clear that part. So but we are true with the question, so that is the answer. So we'll continue with the exercise in next video. Thank you.